Hello there, guys. This is Professor Eric Rodin, and this is 6.5 linear inequalities video. Just want to make a supplemental video to fill in any gaps you have from the lesson from in class. And so I want to go through this a little bit more slowly and carefully. All right, and hopefully get you really confident for your homework and get you ready for the test. So let's get started. So first of all, guys, congratulations. This is the last lesson of the course, and make sure you start reviewing for the final exam. And great Bible verse from Isaiah chapter 40, verse 31. But they who wait for the Lord shall renew their strength. They shall mount up with wings like eagles. They shall run and not be weary. They shall walk and not faint. So if you feel like fainting, if you feel like giving up, we're almost at the end. Keep pushing through. Wait on the Lord. Trust in Him. And do your part. And He will meet you halfway. So you can do this, guys. So this is the inequalities, and basically it's different from equations, and so you can have true or false statements like this one here. It says 2 is less than 7. That is true. Okay, x is greater than 2, but we don't know what those are, so this is just saying what the solutions are for x. So x could be 2.1, it could be 2.9, it could be 3, it could be 100, it could be 1,000,000, and it just goes forever to the right. This is another example of an inequality. We're used to seeing this as equations, but we're going to go ahead and solve them just like equations. And this is called a compound inequality, okay? We're going to talk about this a little bit later. So first of all, a quick reminder about what these symbols mean. So you have the less than, the greater than, the less than or equal to, and the greater than or equal to. So how do you graph on a number line the solution set for x is less than 5? Well, the instructions are right here. You're going to have an open circle, and you're going to shade to the left. So because there's no equal sign, it does not include 5, but we do have to mark it with an open circle, and then we shade to the left. Same thing with greater than. We're going to do an open circle at 5, and we're going to shade to the right. And then once we get to the equal to signs that are right under the inequality signs, we're going to include the number. So we're going to do a closed circle and shade left for less than or equal to. So closed circle, shade to the left. And greater than is going to be, greater than or equal to is going to be closed circle, shade to the right. Okay? Now, so a compound inequality like this one is really saying all real numbers greater than 4, and less than or equal to 6. Now I did do a typo here, so you might want to change your notes. But basically, right here there's supposed to be an equal sign. Okay, so this is correct right here. So this is how we graph compound inequalities. So basically, you don't want to overthink this too much, but this is like saying, an elementary class at your church is going to be from 4 years to 6 years old or something like that. Okay, so basically it's everyone. You can say in between. So you're going to shade in between those two numbers. So you're going to do an open circle at 4 and closed circle at 6, and then just shade in between. Okay, don't try to think too much about that. And so go ahead and I'll give you a couple minutes for you to go ahead and try these. If you haven't done so in your notes, go ahead and complete numbers 1, 2, and 3. See how you do, and I'll be back in a few minutes. All right, so hopefully you're able to work on these and check your answer now. Look on the screen here, and you can see x is greater than or equal to 4. It's shading to closed circle, shade to the right. We have closed circle, shade to the left for the second one. And then the last one, the compound inequality, it's going to be an equals a closed circle at -3, open circle at 2, and then just shade in between, okay? That's basically it. And let's go to the next page to start solving inequalities. Okay, so the next page we have number 4. And so basically, we're not going to treat these any differently than equations. We're going to do the same strategies to solve for x, to get x by itself. We're going to do properties of inequality. Properties of equality. So we can add something to both sides, subtract something to both sides. In this case, you can see that all I did was subtract 2 from both sides as usual. And now we have this answer, but now we have to graph our answer, okay? That's the only really real difference, besides one little thing I'm going to talk about number 5 and number 6. So we have number 5, and looks like a pretty simple, short inequality, but we got to talk about a few things there. So let's see. We're going to go ahead and multiply both sides by 3 to get rid of that 3 right there. So that's going to create a 9 on the left side. And then we see that that's not the final answer, because so we're going to have to do something with that negative x. Okay, you can't leave answers with a negative sign on your variable. So once we do this step right here, oops, that's not right. Just use a -1 to cancel out the negative. That way we get a positive x on the left. But in the process of doing this, guys, the only thing you have to remember with the inequalities, you have to reverse the symbol whenever you multiply or divide by a negative. So that means that this greater than is now going to become less than or equal to. Okay, so now we have our final answer. So we can go ahead and all we need is just a couple of numbers there. You don't need all the tick marks. We're going to do closed circle at -9 and shade to the left. You can see that the less than is pointing to the left with the x on the left. So this is something we have to remember. So let's go ahead. So if you multiply or divide, okay, by a negative, all right, then you have to reverse the symbol. All right, guys, it's time for you to try number 6 if you haven't already. If it's not in your notes, go ahead and work this one out, and I'll be with you in about 2 minutes. All right, let's see how you did. So number 6 is here complete on the screen. And notice that the greater than became less than because of the negative 4 that was divided, okay? Now, if it's a positive 4, you don't have to reverse a symbol. If it's a positive number that you're dividing or multiplying by, you don't have to do this. It's actually, you're not allowed to do it. It's only when you are multiplying or dividing by a negative number, okay? Now, let's take a look at number 7. This one's already done. And this one's kind of weird, okay? So this one, notice that we divided by a positive 4. And, you know, this is basically our answer, but it's not, it's kind of backwards, okay? And so a lot of students get this confused. They'll do less than, they would shade to the left because it looks like it's pointing to the left, but it's always read in terms of the variable. So if I read it with the variable first, starting at the right, it says that x is greater than negative 2, okay? So you have to kind of read it backwards. X is greater than negative 2, and so basically you have to shade to the right. So it's better actually just to reverse the whole thing. So notice that the opening is towards the x, so I'm going to keep it that way. I'm just flipping the order, and so really that's what it looks like, okay? So that one's a little, when the x is left on the right side, it can be confusing, so it's better just to either read it backwards or rewrite it in the standard way, okay? Okay, so now we have some multi-step equations, and let's just kind of go through these and see. These are pretty much done the same way we've been doing the equation. So I'm going to go ahead and there's nothing to simplify in either the right or the left. So we're going to go ahead, I'm going to choose the 6 to move or to collect to the left. That's going to give me 3x. And then we're going to subtract 8 from both sides. That's going to give us negative 12. Then we're going to divide both sides by 3. And since we divided by a positive number, we don't have to reverse that symbol, okay? Then we go over here and graph it. And that again is to the left. All right. Let's do number 9. So number 9, we do have to clean up the left side some. And we can go ahead and take care of the x's. Subtract 11. And then this is written backwards, so it says x is greater than 16. X is greater than or equal to 16, so I'm going to go ahead and just go ahead and reverse that. And then we can graph it. And we're done. All right, so far so good. Nothing too different from what we've been doing before. But let's get to number 10 and talk about that one. So I got number 10 started, and um, notice how we cleared the parentheses from both sides, and then we notice that we get 8x on both sides. So when we collect variables to either side, it doesn't really matter. When you subtract 8x from both sides, the x terms all go away. So this reminds us of what we did in the previous section, where when the x terms go away, you're just left with constants. Whatever's left over, you have to determine whether this is a true or false statement. And this is what we have to do here. So basically, we have to answer the question, okay, that my x terms went away. That's okay. But now, is this true or false? Okay. Is 4 less than -6? Well, of course not, because -6 is further to the left than the 4 on a number line. Positives are greater than negatives, so this is false. Since it's false, remember the conclusion we came to in the other section, and this was a no solution. So how do we graph no solution? And basically, a no solution means there's no graph, okay? So it's in blank graph, okay? There's nothing there it's a blank number line, basically. There's nothing to shade, all right? So you're going to see that in the homework where that is possible. Now, what if it was true? Well, if it would have been true, and we get all real numbers, you would shade the whole thing, basically, okay? So that's a new part here. So all real numbers, if it was true, how would you graph all real numbers? You would basically shade the whole thing, okay? You just shade everything. So that's possible. It's an interesting extension to inequalities. And so let's move on to number 11. Okay, when we get to number 11, we see some compound inequalities. Okay. And so if you see compound inequalities, it's like you're solving two equations at the same time. Okay, so, and that's okay. We just, instead of doing something to two sides, we're going to do it to three sides. Okay, so for example, in number 11, to get x by itself, I'm going to add 4, right? That gets rid of that, but whatever I do to the middle there, I need to do to the left and to the right. So I'm going to do it here and here. Okay, so that's going to produce x by itself. And then I just go ahead and calculate the left side, which is 6, and the right side, which is 10. And that's my answer. And so now we can go ahead and graph this, which you learned how to do in the previous page. So here's 0, 6, there's 10. Whoops. And we graph open circle at 6, closed circle at 10, shade in between, okay? That's what the compound inequality looks like. So why don't you go ahead and try number 12 on your own, see how you do, and then you can check your answer in a few minutes, okay? Okay, so here's the solution for number 12. Hopefully you're done by now. And so notice that subtracted 4 to get x by itself, so I have to do it everywhere. And that produced a -6 here and a 6 over here. And then I divide everything by 2, And so that's going to give me x by itself in the middle, negative 3 on the left, positive 3 on the right. And of course, here's our little line segment thing here where we're shading in between. This time we're including the negative 3 and the 3 as closed circles. And that's it. Okay, so now the last thing you have to know for this section is some word problems. Okay, so it always is good to see, why is this information helpful? How can we use it in our daily lives? And this is a nice budget question, budget problem. Okay, we're all gonna encounter a certain amount of money that we want to spend on something. Okay, so this is a party. Okay, it's a 75th wedding anniversary, and so it does cost money to either to do this yourself or to have go somewhere else and have somebody run the party for you. Either way, it's going to cost money. One requires less work, so it's going to be more expensive. So in this case, you have $2,200 to spend, and for setup and cleanup, which is a lot of work, all right, there's a $200 fee. All right, it also costs $20 per person, right there. So those are your main numbers that we're going to. And so if you have a budget, that means, so you have this amount, right? And you don't want to spend more than that. You want to spend less. So whatever your costs of this party needs to be less than the budget, well, equal to as well. I mean, that just means you used up every single dollar from your budget with nothing left over, but that's fine. It's in your budget. So now, what are the costs involved? We already mentioned that it's a $200 one-time fee and $20 per person that you invite or guest. So if you invite 0 guests, then there's not going to be an extra cost, and you don't want to invite an unlimited amount of guests, so you have to have a certain amount of guests you can invite so you can stay in your budget. So this is our equation, and now we go ahead and solve it, okay? So we just do the normal procedures here. And we get $2,000 to work with after that fee, and then we divide by 20 to see how many people we can invite to stay within our budget, and that's going to be 100 guests. Okay, so that's your max. Okay, so that's a very, very relevant and practical application to solving linear inequalities. Okay, and hopefully you can use that type of a mentality for future issues that you have when you're planning something important and expensive. So why don't you try number 14? There is a little hint here. This is a different type of scenario, but it tells you what to put on the left side of the inequality and what to put on the right side. So go ahead and read that and press pause, check back in a few minutes to see how you did. All right, guys, so hopefully you were able to get this going. So the equation you're supposed to use is basically R on the left side, which is 8x, and C on the right side, which is that equation right there. So if you can see, there's my greater than. So the revenue has to be greater than your expenses or your cost, okay? That's when you can make a profit. So, if you're washing cars every day, that's your full-time job then, or it's your part-time job, doesn't matter. My final answer was 20 cars. So how did I get that? Now, I did use a little technique that you don't have to use, but we talked about this in the last section, where if you don't want to deal with decimals all over the place, you can go ahead and get rid of them right here at the beginning by creating a whole number. And we do that by moving the decimal twice. That means we're multiplying by 100. Well, if I do it to this, I have to do it to everyone involved here, or to each side. So basically my 8 becomes a 800, my 50 cents becomes a 50, and my 150 becomes a 15,000. And so now I don't have to deal with decimals. I just do 800 minus 50, which is 750. And then I do 15,000 divided by 750, and I get 20 cars, okay? So this is just one way to do it. But the point is, if you think about it, if you're doing this every day, you have to get to 20 cars just to pay for your expenses, okay? It could be paying for the location that you're in, the water, the soap, all the different tools that you're going to need. Even maybe paying an employee or something, just doesn't matter. So, or maybe a sign that you have outside. So it's going to take 20 cars a week to basically break even. And then after 20 cars, so let's say you do this all on Monday, then Tuesday, Wednesday, Thursday, Friday is going to be all profit. Okay. So that's a business application. Now let's take a look at the last one. So you're going to need all of these for the homework, but this last one is going to be on the test, okay? And the reason why I chose it to be on the test is because it's so relevant to you guys. I mean, you may not be planning a party, or you may not be, starting a business, but you definitely want to have goals, and you want to know what you need to make on the next test to, make your grade goal. So this is a very simplistic equation because it's only 3 tests, okay? I know you guys have more than that, and I'll show you guys how to do that in class, but basically you just increase the numbers, right? So Eric here has 67, that's a D, and this is a 78, that's a C. So look what his goal is. That's really good goal, all right? Making a D and a C, but in the end you want to have an 80. Well, good. Well, you're going to have to make an A. It's just pretty clear. If you make a D and a C, you're going to have to make up for it with an A to kind of get this all to a B, to average it out to a B. All right. So there's different ways of doing this, guys. I'm going to do it the algebraic way, okay? Algebraic way. You may do this using trial and error or some other way, point system, blah, blah, blah. But I'm going to do it this way. You're welcome to do it how you want, okay? So if we're setting up an actual equation or inequality, here's the first 2 tests. What do you have to make on the next test, which is an X, that's the unknown, and you want to average of those 3 tests to be either equal to or greater than an 80, okay? So that's the basic setup. Now you can go ahead and add up, hey, how many points have I earned so far? So we get 145. That's how many points from those 2 tests. You're going to have one more test. Okay. Multiply both sides by 3 to get rid of this 3 here. And all that just means is, hey, I have 145 points. I'm going to take one more test. And to get an average of a B out of those 3 tests, that's three tests at 80 each. That's 240 points. So that's my goal right there, 240 points. And if this is what you have, which is that 145, you just find the difference. Okay. So I know it's possible to do this without doing algebra, but like I said, I'm just showing you the algebraic technical way to do it. All right, and there is your answer. Like we predicted, we need an A. If you make a D and a C and you want a B, you're gonna have to make up for it with an A, and there's your A right there, 95 on the next test. Okay, I will show you how to do this when we review for our final. That's adding up your scores, what you have, including your homework. Because by then all the grades would be final except for the final exam, and then you can calculate pretty much using the same procedure. Your grade goal. Okay, what do you need to make on your final to get an A or a B or a B plus or whatever you're trying to aim for? Okay. All right, guys. Let me know if you have any questions, and my goal is to send you guys a little practice test video or review for the chapter 6 test. All right. It is going to be a short answer, so just want to make sure you guys are prepared for that. All right. See you later. Have a great weekend.